Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 158. Page 158, and today is our lesson number 47. Let's take a look at it. Problem number 43. On page 158, the very first problem on the page, they give us a little diagram. So let me reproduce it here very quickly. One, two, 1, 2, 3. First one is here, that's point P. And they tell us that is 0 and -1. And then we have 2, 1. And a 3, 2. And they're calling this point Q. The question is very simple, very straightforward. The question is the point that is twice as far, the point that is twice as far from P as it is from Q. What is that point? Well, that's, as I said, it's very simple, very straightforward. From here to here, whatever the distance is, I mean, I'm not going to call it but whatever the distance, let's call it 1 unit. From here to here is 1 unit, and from here to here is another unit. So whatever the units happens to be here, you don't have to calculate this thing, you don't waste your time here, just understand that this distance is same as this distance and that distance is same as this distance. So the distance that is, the point that is twice as far from P is this point right here. Right, this guy right here. This point is twice as far from P because it's 2 units away, and 2 units away from P, and is 1 unit away from Q. That's it, that's the point. And the coordinates of those points are 2 and 1. 2 and 1, that's it. The answer is 2 and 1, and that's point. Where is the picture? I lost it. That's it. Let's call it point R. So the point R is with x coordinate of 2 and y coordinate of 1. That's it. Now what would have happened? Right here. What would have happened if they ask you the point that is twice as far from Q as it is from P? The point that is twice as far from Q as it is from P would have been this point. This point right here, 1, 0, that point right there, 1, 0, let's give it a name here, we have P, Q, R, let's call it S. P to S, 2 times that amount is same as Q to S. But that's not what they're asking. This answers this question. But the question that they're asking is, what is the point that is twice as far from P as it is from Q? The point that is twice as far from P is point R. Point R, which is 2, 1. And the reason is because in that case, the distance from P to R is 2 times as much as distance from R to Q, which is what we're looking for. And that answers the question that they are asking. That's all. We're done with this one. Let's do the next one. Enough of this thing. Let's do the next one. That's all it is. Let's do question number 44. If n is an integer, which must be which must be even. Well, if n is an integer, there are only two possibilities. N is either even or odd. There are only two possibilities. N is either even and or odd. All we have to do is contemplate both possibilities and find one answer choice that does not switch. For example, the very first answer choice that they give us is n plus 1. N plus 1. In the case of n plus 1, if n happens to be even, let's say 2 plus 1 is odd. But if n happens to be odd, then odd plus 1 will be even. And the question is, which of the following must be? That use of the word must means we are looking for something that has to be true all the time without exception. Here, n plus 1, is it even? To which the answer will be not necessarily. Is n plus 1 even? Is n plus 1 even? The answer is not necessarily. Not necessarily. Yes, n plus 1 is even. If n plus 1 is even when n itself is odd. But if n is even, then n plus 1 is odd. Let's do the next one. So that was A. In B, the question is n plus 2 even? Is n plus 2 even? Again, the same problem. If n happens to be even, then of course n plus 2 is going to be even. But what about if n happens to be odd? If n happens to be odd, then odd plus even is going to be odd. It's not going to be even. So again, the answer is not necessarily. Not necessarily. In C, the answer is that they give us 2 times n. Now this gets interesting. When it's 2 times n, 2 of course is even, all right. What happens if n happens to be odd? If n happens to be odd, then even times odd. You don't have to memorize this thing. There's no need to memorize it. I never do. Just plug in numbers and find out. 2 times 3 is 6. Oh, voila. So looks like even times odd is even. So this quantity turns out to be even. But what if n happens to be odd? What if n happens to be odd? Odd times odd. Let's find out what that is. Odd times odd. Again, don't memorize it. As I said, just plug in numbers and find out. Only takes a second. 3 times 5 is 15. Odd times odd is... Sorry, I made a mistake here. It's not odd times odd. I'm not paying attention. It's 2 times n. So if n happens to be odd, then 2 times odd number, 2 is even. Even times odd, we just found out is even. Even times odd, we just found out is even. But what if n happens to be even? If n happens to be even, 2 of course is already even. 2 of course is already even. I'm not going to put down 2 even here. I'm going to actually put down 2 here to emphasize. 2, which is an even times even. We're not looking for this part. Even times even. 2 times 4 is even. So it doesn't matter. It doesn't matter. It doesn't matter whether n turns out to be odd or n turns out to be even. In either scenario, even if n turns out to be odd, the fact that we're multiplying it by an even number, odd times even, that's the bottom line. Odd times even is even. And if n turns out to be even, still doesn't matter, because even times even is also even. So it doesn't matter whether n is even or odd, the fact that it is being multiplied by an even number, 2 that is, because it's 2n. Okay, one more time. It doesn't matter whether n is odd or even, the fact that it's being multiplied by an even number, therefore even times even is even and even times odd is even. It's always even. And the question was, which of the following must be even? Must be even? Well, there you go, that's your guy. This is something that has to be even. That's the answer. Now, just to satisfy our curiosity, let's take a quick look at D and E. In D is 2n plus 1. Now when would this have been the correct answer? This would have been the correct answer if the question were, it's a purely hypothetical statement. If the question were, which of the following must be odd? Which of the following must be odd? This is going to be odd because we just found out that this quantity is always even. Even plus 1 is going to be the odd. This is going to be odd. So if we were to change this, which of the following, if you were to change this question, which of the following must be odd, then the answer is this. Answer will switch. And finally, we have n squared. Finally, we have n squared. The problem with n squared is that if n happens to be odd, then odd times odd, because it's being squared, it's the same number. Odd times odd, 3 times 5 is 15, which is odd. But if n happens to be even, then even times even is even. So it depends on the n. If n is even, then of course it's going to be even. N squared is going to be even. But if n happens to be odd, then n squared is going to be odd. So this is not. Here, question is n squared even? To which the answer is not necessarily. Just like before, not necessarily. That's all. That's it. That's all we are done. I will see you tomorrow, okay? Bye now.